back to organic chemistry, students. And till now we have been studying general organic chemistry, alkanes and alkenes. Now let's move on to this third part of hydrocarbons, which is alkynes. First, in alkynes, let's quickly wind up the theory which we have already studied. First, let's begin with the preparatory methods. I have dealt only with a few methods, and most of the preparations will be done as the chemical properties of some other compounds like alkyl halides, or even if you take alkenes, which we have already done. Now, in the first one, we start with hydrolysis of carbides, where we take calcium carbide and subject it to hydrolysis. You end up getting acetylene, which is C2H2. It's called acetylene, and you also get calcium hydroxide. So the solution will be basic one. Basic. Now, the second method of preparation is dehalogenation of vicinal tetrahalides. Not dihalides, it's tetrahalides, because you have 4 halogens and these are vicinal because, as I already told you, this is called vicinal, and you have 2 vicinals like this one and this one, and you have it's tetra because you have 4 halogens. Now, whenever you subject it at high temperature in the presence of zinc, this loses electrons. This carbon loses electrons to this X halogen, and zinc gives electrons to it, and this loses electrons, this carbon, and hence this obtained negative charge forms a bond here, and you will get triple bond here. The mechanism is already told to you. And the third one is double dehydrohalogenation of gem dihalides. That is, consider this one, which is a gem dihalide. If you treat it with KOH in ethanol at high temperatures, you will get an internal alkane as shown in this one. But whereas if you treat it with NaNH2, you will get a terminal alkane as shown here. Remember this, it's an important one. Now, the third part of it is completed, and let's move to the chemical properties of it. Now, before we start with the chemical reactions, you should notice that alkanes are less reactive than alkenes towards electrophilic addition reaction, because in alkynes the carbon is sp hybridized, and if you know that it has 50% S character, whereas in C double bond C it is sp2 hybridized, it has only 33% S character. Now, since it has more S character, it has more penetration power, and so it exerts more pull of nucleus towards electrons. As a result of it, this is reluctant to give its pi electrons towards electrophile than C double bond C. And now, as a consequence of it, if you have a reaction where C triple bond C undergoes electrophilic addition reaction to give C double bond C, this will further undergo addition reaction to give C single bond C, because this is more reactive than this one. If this can react, this will automatically react to give an alkene. First, one more thing to note is that for terminal alkane, if you take, this hydrogen is acidic because the carbon here is sp hybridized, and it has more electronegativity than sp3 carbon. If you take CH3, say R, it is sp3 carbon, and this is sp carbon, and it is more electronegative, so it can pull the bonded electrons towards itself owing to release of H plus ion. And if you treat it with Tollens reagent, which is ammonical silver nitrate, you will get a white precipitate. Whereas if you treat it with Bendix reagent or copper tartarate in the presence of NH3, you will get a red precipitate. Remember, these are tests to find out if there is any acidic hydrogen, or these are tests to determine the terminal alkynes. Now let's move on to the next part. Next reactions of alkynes is permanganate oxidation, where you take an alkyne as shown in this one, and if you treat it with hot warm water, you will get this one, an acid, and this is also an acid. Now if you treat it with cold alkaline KMnO4, which is called Bayer's reagent, which is already taught to you, you will get diols as shown here. Now it's present in the basic medium, and in basic medium it can undergo tautomerization to give a diketo compound. It's a diketo compound. The mechanism of it is taught to you in your solved examples. Now let's move to the next part of it. So next part of it is the polymerization reaction. It's a very simple one. You take, for example, acetylene, heat it at high temperature in the presence of copper, then it gets converted to benzene. It's shown to you here. Consider these 3 acetylene molecules as shown here. Now at high temperature, what happens is bond shifts occurs, just like as you remember that Diels-Alder reaction. It's a pericyclic reaction. This is also the same way. It will give you benzene. Now if you take, instead of acetylene, propyne, what you will get is this compound, CH3, CH3, CH3. Try it out yourself by putting one more CH3 here and on here and on here. You will get the compound. And the next reaction is coupling of terminal alkynes. As you can see here, this is formed when this terminal alkyne is treated with Bendix reagent. This is already taught to you in the previous one. So when you treat this with oxygen at high temperature, you will have CO and you will get a coupled product. Now let's move to the next part. Let's study some more interesting reactions of alkynes. First one is addition of HX. It's very much similar to addition of HX to alkenes, where you will get a Markovnikov addition product like this one, where you have alkene attached to a bromine, and if you add excess of it, you will get a gem dibromide. I'll tell you why you get only gem but not vicinal. If you take this alkene, say H plus is electrophile, it attacks here, you will get a carbocation here. Now bromine has lone pair of electrons. It can donate its lone pair to carbon, providing it octet stability. Double bond Br plus Cs. So this carbocation is stabilized. As a result of it, we are getting a gem dibromide. Now let's move to the next part of it, which is ozonolysis. It's very much similar to ozonolysis of alkenes, but only thing is that we get acids here. But if you take an alkene like RC double bond C R dash, you will get ketone, or if it is H, you will get aldehyde, say RC double bond OH and R dash C double bond OH. Whereas if it is some X or R double dash, say, you will get RC double bond O R dash, which is a ketone. Now let's move to the next part of it, which is hydration reaction. Hydration reaction is nothing but addition of water, that is H plus and OH minus. At first you add H2SO4, which is supplying H plus. It will undergo electrophilic addition reaction attacks here, you will get a carbocation here. So here OH will attack. This OH is from water, and in acidic medium it undergoes tautomerization to give a ketone. The mechanism of this tautomerism is taught to you in your solved examples. Just have a look at them. Now next one is addition of halogens. Whenever you add halogens to an alkyne, say here I have exemplified it by taking bromine to an alkyne. If you add this one, you will get a vicinal tetrabromide as shown here. The mechanism of it is taught to you in your alkenes chapter. Now let's come to the last part of it, which is addition of HBr in the presence of peroxide. Now this is well known effect called Karsh effect. It was already dealt with you in detail. Now here is the case for alkane. If you take HBr in the presence of peroxide, you get an anti-Markovnikov product, and if you add excess of HBr, say here you take 1 equivalent. If you add excess, you will get one more Br, which is anti-Markovnikov product, that is here, and so this you will get a gem dibromide again. So here we ended the theory on alkynes. Let's move into solved examples.
Let's start off with our first question on alkynes. It's given to you that you have to identify the products in the following reactions of the given alkyne, where R is any kind of an alkyl group. We have sodium, we have
Sodamide and NaOH, which is a base.
Alright, so let's get started, Gopi.
Yes. First thing is, you need to know that this is a terminal alkane, because C triple bond C is present on the last carbon chain.
Okay. Does it mean it's slightly acidic?
Yeah. This hydrogen is slightly acidic. I'll tell you the reason for it. C triple bond C, in it carbon is sp hybridized. That is, it has 50% of s character. Now s orbitals are closer to the nucleus, as you know,
okay,
than p orbitals. So as a result of it, they have more nuclear pull.
Okay.
That is, this sp carbon has more tendency to pull these bonded electrons towards itself.
Okay.
That's why.
So H will have a slightly positive charge on it.
Yeah. So, in the presence of very strong acid, because it's slightly acidic, it gets converted to acetylide plus H plus. This one we call as acetylide. Now, let's look into the question, where in the first case we have our alkyne with Na. Now, the tendency of a metal is to lose electrons, so it will give Na plus electron. And here we are getting acetylide and H plus. And now sodium gives this electrons to H plus, and this acetylide gives its electrons to Na plus. So there is an electrostatic bond between acetylide and Na plus, and you got hydrogen gas, that is Rc triple bond C minus Na plus plus half H2. Now this is called as sodium acetylide. Now this seems to be very simple. Now let's move to the second part of it, where you have treated this with sodamide, that is NaNH2. The thing is, just like the previous one, it gets split to Na plus and NH2 minus. And the same thing with this alkyne, you get acetylide and H plus ions. Now electrostatic bond exists between these two. So you get again sodium acetylide, and NH3 gas will be released out.
Okay.
Very simple one. Now let's come to the third part of it, where you have treated this one with NaOH.
So sodium will
Na plus?
substitute it
Yeah,
and
it's a base.
we'll get H2.
Yeah, that's what all of those do basically.
Okay.
All C triple bond C minus Na plus and H2O.
So basically, for the reagent that is being used, whatever is the part other than the metal that is going to bond with a hydrogen and form a compound.
Yeah,
Right? Fairly
it's
straightforward.
basically acid-base reaction.
Ah, yes, it's an acid-base reaction.
So, but do you think that IIT JEE will ask such a simple questions?
Okay, alright. Yeah, I think that's doubtful. So, what are we missing?
Yeah, I'll tell you that. The first part is correct.
Okay,
Second part is correct as we thought.
okay,
But there is a catch with the third part. It's wrong.
okay.
The answer is the reaction doesn't occur.
Oh, why is that so?
I'll tell you this. Or you can say that the backward reaction of it occurs.
Okay,
Because if you look into the Lowry-Bronsted acid-base theory,
okay,
whenever an acid, say 1, reacts with a base, say base 1, the acid will give its corresponding base, say base 2,
okay,
and this base will give its corresponding acid, say acid 2.
okay.
Now, both the acids have tendency to lose H plus ions.
Gopi, hold on for a second. Can you please clarify for us what is acid 1, base 2, and acid 2 as such?
Yeah, I'll give a clarification for you. If you take the third reaction, this one, this is acid 1
Alright,
and this is base 1
okay,
and this is acid 2. This is base 2.
okay. So basically, anything that gives a hydrogen atom,
Yeah,
we are sort of calling it an acid,
yeah,
while anything that has a negative charge on it, we are calling it a base,
Yeah.
as such, right? Okay, which is being stabilized by a metal in this case.
yeah.
Okay, so let's continue.
So if you look into this part, both these acids have tendency to give H plus.
Yeah.
Now, for this reaction to be feasible, this acid 1 must give more H plus to base 1.
Okay. Then acid 2 to base 2.
Yeah,
Okay.
because if it happens, then this reaction will proceed in a forward direction.
Alright.
But if you take this acetyl alkyne and water, the electronegativity of this carbon is less than the oxygen, because oxygen is more electronegative.
Okay.
So what happens is it has more tendency to pull electrons
Alright.
than this one.
Okay.
So it can more easily lose H plus ions.
Alright.
That is, water is more acidic than this alkyne.
Oh. So the reaction will be favored in the backward direction.
Yes.
Okay. So as a consequence, we won't get this particular product
Yeah.
itself. Oh, alright. So, guys, as we said, why will JEE ask you an easy question? And this is something that you should keep in your mind constantly throughout all questions in chemistry. If a question looks too easy, there's got to be a trick around it somewhere or the other, right?
Yes.
Okay, so let's move to the next question. We're done, right?
Yeah.